In lesson 20, they start off with us modeling a function based on a skit from Futurama.
We don't seem to have your retina scan, your fingerprint, or your colonic map on file.
Yeah, well, I did open the account over 1,000 years ago. What about my ATM card?
Do you still remember your PIN number?
Sure. It's the price of a cheese pizza and a large soda back where I used to work. Panucci's Pizza.
Okay, you had a balance of 93 cents.
All right.
And at an average of 2.25% interest over a period of 1,000 years, that comes to $.
All right, let's set up a function right here that describes that scenario. It's obviously going to be exponential growth. All right, so normally our function is y equals or f of n. This one I might do f of t for time equals, and then we always start with our principal amount. The principal amount that Fry put into the bank or deposited was 93 cents, so 0.93. Then we're going to multiply that by, it says, how much did Fry have in his account after 1,000 years? So I wouldn't just put the interest rate on there because I also want to include the amount that's in there, not just how much interest he earned. So I would have the 1 point and then change this to our interest rate. You're going to move that decimal 2 times to the left. So it would be 0.225, and that would be to the t. Ta-da, right? It says, how much did Fry have in his account after 1,000 years? Oh, all right. So I'm going to take off that t, and that's when I'm going to put in 1,000. All right, so try to enter that into your calculator. All right, the total amount, if you put that in, should have been somewhere around, oh my goodness, very large number. Look at that. All right, let's see if we're right. Here's our final answer right here.
And at an average of 2.25% interest over a period of 1,000 years, that comes to $4.3 billion.
All right, they said 4.3 approximately. Is this going to get us 4.3 billion? If we rounded that, yeah, absolutely. That's approximately 4.3 if we rounded $1 billion. They would definitely not round up for you though. All right, let's go to the next page. All right, the next page, there's 3 main ways used to measure temperature: Celsius, Fahrenheit, and Kelvin. So across the top, we've got Celsius, I've got Fahrenheit, and Kelvin. All right, they're different measurements. They want you to graph the data below, but watch out, there are different comparisons here. All right, so the first one is Celsius. I'm going to read the graph down here. Celsius is along the x-axis. Kelvin is right here. And then in the next graph, we also have Celsius down here, but now it is Fahrenheit. They are going to be 2 different graphs. Go ahead right now, try to graph it. All right. Now, this is just an estimate. You're going to look up here, remember? In both cases, they have Celsius along the x-axis, but then one's Fahrenheit and one is Kelvin. All right, so I've got somewhere around here. Looks like it's kind of growing steadily, right? And it might not be exact because it's not exact, but at some point we should have some kind of a line that looks maybe like that. All right, and then if I do the next graph, it starts really far down here. All right, and so forth, and it goes all the way up here. So maybe the pattern might be closer to something like that. All right, big difference. So on the next page, let's answer some questions about both of these graphs. All right, so B asks which model would be best for this data. So you would look back at that, and it looks like, based on the information they gave us, that both of them would fit a linear model. All right, both use a linear model. All right, does it make sense to connect the data points? This is important. This is the difference between discrete and continuous. We've talked about this before, and I know for sure it's on your test, so pay attention. All right, would we want to connect these or leave them separate? Well, temperature doesn't just jump randomly. It has all the temperature in between each point also. So this should be continuous. All right, temperature is continuous, so does it make sense to connect them? Yes, it does. All right, I'd write something down like temperature is continuous. All right, D, write an equation relating temperature in Celsius to temperature in Fahrenheit. So that is our second graph. It's going to be a little steep, right? So I would write maybe F for Fahrenheit. Okay. So the function of Celsius and Fahrenheit, I definitely want to find my starting term, my y-intercept. It looks like, look right here, somewhere near 32. So that's a positive 32. And then find an average rate of change. Is it going to be exact and perfect? Not necessarily. All right, you could even use the table up above. Look, you can find the rate of change between these. They're going up by tens. On Celsius, what's the Fahrenheit going up by? And then write an equation. I got 1.8, maybe Celsius. All right, that could be your X and Y. This could be your X, that could be your Y. Don't get scared over the variables. All right, the next one, write an equation for Kelvin. So I might do Kelvin in terms of Celsius. So do the same thing and write a formula for this one. All right, you should notice that, oh, it's going up. It's increasing by tens and tens. Oh, I got Celsius plus 273. All right, I'm going to check that because that looks a little weird. Celsius compared to kelvins. All right, here I go. So I'm going to go to this next one. All right, this went up by 10, and this went up by 10. Oh, look at that, 10 over 10. Let's see if it continues. That went up by 10, so did this. It looks like I've got a slope of 10 over 10. Look at that, 10 over 10 is just 1. If you want a 1 there, you can put it there. Good. All right, what is the temperature in Fahrenheit if the Celsius temperature is 15 degrees? So all you're going to do is plug in 15 degrees for your X value or for your C. Plug those in, and you should get an answer for Celsius at 15 degrees and Kelvin. Oh, I feel like that first one should be Fahrenheit. Sorry about that. Oop, that should be Fahrenheit. All right. Be nice if I could spell it too. Okay, Fahrenheit. Good. All right, if you did it correctly, you should end up with 59 degrees and 288. Woo! Yeah. All right, let's look at G. If the Kelvin temperature is 300, whoa, look at that. All right, what is the Celsius temperature? So the Kelvin temperature is 300. So we're going to use this formula right here, but now I know the output is 300. All right, and then it says the Fahrenheit temperature. Oh my goodness. All right. So then for the Fahrenheit, I would use that equation and substitute in. Okay, if you solve this, you should have gotten 27. So now I'm going to plug that in for f of 27 equals 1.8 times 27 plus 32. See, I'm using that Fahrenheit equation. All right, so we're just kind of going back and forth between these tables and formulas. All right, let's look at H. If the Fahrenheit temperature is 300 degrees, what is the Celsius temperature? All right, we're still going to use the same second equation, aren't we? All right, so let's figure that out. First things first, there's kind of two parts for it. All right, so I'm going to use the first equation. 300 equals 1.8 Celsius plus 32. All right, solve for C. You should get C is approximately 148.8. All right, and now that I have that, I'm going to use that to convert into my Kelvin equation. All right, so the Kelvin equation is Kelvin of 148.8 equals 273. All right, see how I'm using that? Plus 1 times the Kelvin of 148.8. I ran out of room. That equals 421, repeating 8. Whew! All right. Our final answer or question is I. I like this one better. All right, it says, what is the domain and range of the situation? So let's do Celsius to Fahrenheit, and then I'll do Celsius to Kelvins. I have two different ones, right? So let's do the domain. The domain, you're going to look back either at your table or your graph. I'm going to look at the table. What's the smallest x value, or Celsius? And it equals 0. And then the largest x value goes all the way up to 100. All right, and then the range goes from 32 degrees Fahrenheit all the way up to the biggest number in your table is 212. Nice. All right, the last one. Celsius to Kelvin. Okay, and these are also going to be square brackets because they equal it. So my table starts from 0 to 100 the same way. But then this time the range is the Kelvin. Look at the kelvins in the table. They start at 273 and go up to 373. Dun, da, da, da. That's it. All right, so we're just kind of looking at different charts and different equations to model scenarios. All right.